All right, let's dive in. Today, we are talking about this brilliant, almost paradoxical idea that powers all those incredible AI image generators you see everywhere. We're going to go from pure chaotic noise to crystal clear, amazing creations.
So let's just start with the most basic question, right? How in the world do you teach a computer to create something genuinely new? To make a picture of a cat, or a car, or a landscape that has literally never existed before.
Now, you'd probably think the answer is pretty straightforward. Just show it millions and millions of finished pictures and say, hey, learn to make one of these. But that's not really how the most powerful models we have today learned. The breakthrough idea was something else entirely, something kind of counterintuitive. Yeah, the real secret was teaching the AI not how to create from scratch, but how to undo destruction. It's wild. You take a perfect image, you methodically, step by step, destroy it until it's nothing but random noise. And then you train a model to masterfully reverse that entire process. That's the core concept, the big idea from the groundbreaking 2015 paper that really got this whole thing started.
Okay, but why? Why was this totally new approach even necessary? Well, before diffusion models came along, AI researchers were kind of stuck. They were facing what you could call the generator's dilemma.
So for the longest time, the models that tried to generate things were, well, they were stuck. They had this massive trade-off. On one side, you had these simple, tractable models. Think of them like stick figures. They're easy to draw, easy to work with, but they're way too simple to capture the rich complexity of a real photograph, right? Then, on the other side, you had these incredibly flexible models that could, in theory, describe anything. But they were so complex, they were basically impossible to train. So researchers were just hitting a brick wall. And the solution, believe it or not, didn't come from computer science. Nope, it came from a field that is an absolute expert in chaos and order, physics.
The authors of that 2015 paper really said it best. They got their inspiration from thermodynamics. I want you to picture this: a drop of ink slowly diffusing, spreading out in a glass of water. They realized, hey, we can apply that exact same principle to data. First, you destroy the structure, and then you learn how to put it all back together again.
So, okay, let's get a little formal for a second. What is a diffusion model? Well, it's a generative model that works by reversing something called a Markov chain. Don't let the name scare you. A Markov chain is just a fancy way of saying it's a sequence of steps, where each new step only depends on the one right before it. So you have this very predictable, step-by-step process of turning a clean image into noise, and the model's entire job, its only job, is to learn the reverse of those exact steps. So let's look at the first half of that. Let's look at the path of destruction, this controlled demolition of an image.
Okay, so the forward process is actually super simple, and it's fixed. It never changes. You start with your data, let's say a clear image. Step 1, you add a tiny, tiny bit of random noise. For step 2, you take that slightly noisy image and you add just a little more noise. And you just repeat this over and over and over again. We're talking hundreds, sometimes thousands of times.
And where does this all end up? Where does this path of destruction lead? Well, it leads to a very simple, very predictable destination. A cloud of pure, structureless static, what we call Gaussian noise. And this is the crucial part, you guys. No matter how complex that starting image was, a face, a galaxy, anything, the end point is always the same simple, random pattern. All right, now for the magic. This is the cool part. We've got the path from a perfect image to total noise. The AI's entire job is to learn how to walk that path backward, to go from noise all the way back to the image.
So this reverse process, this is where all the learning happens. The model starts with a fresh patch of random noise, exactly like the static we ended with. And then, step by step, it tries to undo the damage. It carefully removes just a tiny bit of noise at each stage, slowly revealing the structure hidden underneath.
And this is the key to why this whole thing works so darn well. The model doesn't have to learn how to create a whole cat in one giant leap. No way. It just has to learn how to make a really noisy picture of a cat slightly less noisy. And learning to make those tiny, incremental changes, well, that's a much, much more manageable task for a neural network.
So, okay, this whole idea of destroying something just to rebuild it, it sounds really elegant, right? But did it actually work? Let's take a look at what that original 2015 paper was able to pull off.
First off, these were not shallow models. We're talking incredibly deep, often operating over 1,000 or even more time steps. And that depth
is what allowed for that super gradual, fine-grained process of removing noise that was just so critical to making this whole thing work.
And this depth, it unlocks some seriously impressive new capabilities right from the very beginning.
For starters, the model was able to generate really convincing handwritten digits. That's kind of like the hello world for this kind of AI. It would start with a patch of static, and step by step it would magically resolve it into a clear number 3 or 8. But it didn't just stop at simple digits. It could also generate small, but much more complex natural images from a dataset called CIFAR-10. We're talking about things like blurry but definitely recognizable cars, birds, and ships. This was a huge leap in complexity. The model also had some really cool practical applications built right in. I mean, think about it. If you give it a real photograph that's all noisy and grainy, it can use what it's learned to run the process in reverse and just clean it up. It literally removes the static to restore the original image. And then there was this, which is maybe the most impressive part. It could do something called in-painting. So you could take an image, literally cut out a huge chunk from the middle, and then ask the model to fill in the blank. And by looking at all the pixels around the hole, it could generate brand new content that believably completed the picture. I mean, that is a true demonstration of it actually understanding the context of an image. So all of this leaves us with a pretty deep final thought, doesn't it? This whole incredible creative process is built on reversing chaos. The model learns to find the signal in the noise, the structure in the static. So you have to ask yourself, if an AI can learn to find perfect order in total chaos, what is the limit to what it can create?